The human skeletal system is a marvellous construct designed to support us, move us and protect us. It works so well that we often take it for granted. But what happens when something goes wrong? Currently, there are only a few options available to surgeons to repair bone tissue that has been badly damaged by disease or injury. These mainly consist of grafting a new bone, either from the patient or a donor. Roughly 2.2 million of these procedures are performed worldwide every year, and they are fraught with risk and complication. But what if we could build our own bones?
My name is Mealy and I'm a PhD candidate here in the Trinity Centre for Bioengineering. My research aims to produce a commercially viable ceramic scaffold that can be used to repair damaged bones. So my research takes a cyclical approach. I start with a formula or a recipe for a scaffold, which I then make using a freeze-drying and sintering technique. Let's make a scaffold.
Making a ceramic bone scaffold is a lot like baking a cake. First, the ingredients need to be measured. Then we need to mix them together. The freeze dryer allows me to give my scaffolds their porous structure. I can cut the scaffolds to any shape I want. And finally, I fire the scaffolds in a furnace to give them their mechanical strength.
I can then analyse this scaffold using micro-CT imaging and scanning electron microscopy. I can use these images to have a look at the scaffold surface to see how the cells might behave on them. I can also use the images to build a 3D model of the scaffold, which I can then use to see how the scaffold will perform when it's finally implanted into a patient. So I can use what I learn here to inform my design, change my recipe and try and get the scaffold properties that I need.
Here in Cran, in Trinity, I can use the scanning electron microscopes to get really detailed pictures of the scaffold surfaces. This helps me see what kind of surface the bone cells will prefer. The micro-CT equipment in the Department of Mechanical and Manufacturing Engineering in TCD allows me to generate hundreds of slices through each scaffold. I can then put these back together to make a 3D model which I can simulate on the computer. This simulation allows me to predict how the scaffold would perform once implanted into a patient.
So in the next 2 years, I hope to be able to bring all of this research together to produce a safer and more viable alternative to bone grafting procedures.